Now we are going to do adiabatic process. Adiabatic process. In adiabatic process, out of Q, this is the first law. And in adiabatic process, this is zero. Because this is zero, we have delta U is equal to minus W. Okay. Delta U is equal to minus W. And in adiabatic process, it is found out that PV raised to gamma is a constant thing. So where gamma is what? Gamma is the, have you heard of gamma before? Or is the first time I'm referring to gamma as? Gamma is Cp by Cv. Okay. Gamma is Cp by Cv. And for monoatomic gases, gamma value is 5 by 3. And for diatomic gases, gamma is 7 by 5. So these two will be asked in your syllabus. Okay. So you have to understand what is the meaning of PV raised to gamma is constant. For example, if there is a gas at some pressure, volume, and temperature P1, V1, T1, and you do an adiabatic process, you let's say you expand it, or you make it go through a process, okay, such that its new pressure, okay, such that its new values are P2, V2, and T2. Okay, so these are two states. You have undergone this gas through a process, which is adiabatic process. Then how will be the P and V related? Is that if this was an adiabatic change, then P1 V1 raised to gamma is equal to P2 V2 raised to gamma. The power is only on the volumes, it is not on the pressure. Okay, the power of pressure is 1 in there. Okay, fine. Okay. So sometimes questions are directly asked here like this. That question will be that was a gas which was adiabatically compressed to 1/8 volume, to 1/8 of its volume. Okay, fine. Or also because you need to put the gamma value, they will give you which gas is it. So from that, accordingly, you have to decide whether it's monoatomic or diatomic. Okay. Yeah. And one thing more, all the inert gases, they don't pair up anything, they're inactive. So all the inert gases are monoatomic. Okay. And I think we have discussed it before also, monoatomic, diatomic, have we discussed before? Okay, so let me ask, chlorine gas will be mono or dia? Just show me fingers. If mono 1, dia 2. Yeah, very good. Nitrogen 2, correct. Helium 1, because helium is inert, so it is monoatomic. Oxygen, carbon dioxide. No, yeah, it's bad question. Carbon dioxide is not. Ozone 3. Ozone is 3. Oh, 3, you should know. Oh, 3 is 3. थोड़ा केमिस्ट्री भी जान लो. ओके, और आर्गन 1. All inert gases, helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon are monoatomic. Okay, so this will also be given that whether the gas is mono or dia. So let's say a monoatomic gas. Okay, this information is also given that this is monoatomic gas. Now the question is find PF ratio PI. So find the value of PF, like the ratio, the final pressure to initial pressure. So the method is very simple. You write PI VI raised to gamma. अब gamma कितना है मोनो का वो डालना पड़ेगा, which is 3 by 2 is equal to PF VF raised to 3 by 2. Now you will put that VF is out. It is VI by 8. If you put that, you will get PI vi raised to 3 by 2 is equal to pf vi by 8. So in place of vf, I'm going to write vi by 8 because it is given that the final volume is 1/8 the volume of the initial. So vi raised to 3 by 2 is common in both, is common in both ends. I will cancel it. Okay. And pf you will get as 8 raised to 3 by 2 into pi. Understood? Everyone has understood this?
Sir, I have a doubt.
Yes.
Sir, how did you get VI raised to the power VI and VF raised to the power 3 by 2?
कैंसिल हो रहा है दोनों साइड, क्योंकि यहाँ पे देखो लेफ्ट साइड में vi रेस टू 3 by 2 है.
Sir, how did you get 3 by 2?
वो तो फॉर्मूला है ना, एडियाबैटिक प्रोसेस है, तो p1 v1 रेस टू गामा मोनो.
Okay,
सॉरी
gamma.
सॉरी, मैंने एक चीज गलत लिख दी है यहाँ पे. माय
It's
बैड, माय बैड.
supposed to be 5 by 3.
इट इज सपोज टू बी 5 by 3. माय बैड, माय बैड. इट इज 5 by 3, इट इज नॉट 3 by 2. So 5 by 3, 5 by 3. So you will get 5 by 3, 8 raised to 5 by 3. Okay. Understood? And 8 raised to 5 by 3, 8 को लिख सकते हो, you get 2 raised to 3 raised to 5 by 3. You will finally, you will get 3, 3 will go, you'll get 2 raised to 5. 2 raised to 5 is 32. So you'll get pf is equal to 32 pi. Okay. And therefore, what is pf by pi? Pf by pi is 32 is to 1, or just 32. Okay. Understood? This is the answer. Okay. This is a JEE Mains, previous year JEE Mains question. Easy questions are asked. Okay. Now but you should remember in the exam, जैसे मैंने ये गलत कर दिया यहाँ पे ना, ये नहीं करना है. You should also realize मोनो नहीं देंगे, वो बोलेंगे आर्गन. एग्जाम में मोनो नहीं दिया है, आर्गन दिया है. So you should know कि आर्गन is monatomic. You should realize these are the mistakes point. You will not realize argon is monoatomic. Then even if you realize monatomic, you will do a mistake like me. You will write 3 by 2 instead of 5 by 3, right? Sometimes you will get till here and then you will do 8 raised to 5 by 3. Some people, some smart people write some other power, they'll write it's 4 or 16 or 64, right? ये सब mistake होती हैं, ठीक है? Okay. Sometimes at the end you will do mistakes. 1 raised to 32. For every mistake you do, there is an option. Okay. So that's why be very careful. Okay. Easy problems, but keep your eyes open. Okay. Now, so this was adiabatic process. Let us see what is the formula for work done in adiabatic process. In general, any work dw is pdv. Do you remember in isothermal the process was pv is equal to constant, and we put pv equal to nrt mein. In place of p we put nrt by v and we integrated. So here what we will put, यहाँ पे pv raised to gamma constant है ना? तो हम डालेंगे that it is constant by v raised to gamma, है ना? समझ में आया? p को डालेंगे constant by v raised to gamma dv. ठीक है. तो k फिर ये जो वॉल्यूम का आएगा v रेस टू माइनस गामा का इंटीग्रेशन आएगा 1 माइनस गामा बाय 1 माइनस गामा. ठीक है. एंड दैट yeah, now see this. This is k by 1 minus gamma can be outside, and you will put limits, right? If you put limits here, इस पे लिमिट लगाओगे ना कि initial to final, right? So you will get v final raised to 1 minus gamma minus v initial raised to 1 minus gamma. Yes or no? Right? अब ध्यान से देखना. Now I'll let the k enter this. I will let the k enter this. If I let the k enter this, this will be 1 by 1 minus gamma into k vf raised to 1 minus gamma minus k vi raised to 1 minus gamma. Okay. Now what is k? K is nothing but k is a constant, right? Which is also, so if it is pi vi raised to gamma, that is also equal to k, and pf vf raised to gamma, that is also equal to k, right? So I will put ये वाला यहाँ डाल दूंगा और ये वाला यहाँ डाल दूंगा. Okay. So that first k is pf vf raised to gamma. So pf into vf raised to gamma into vf raised to 1 minus gamma. that will be Vf raised to 1, because powers of V will be added. If you put this K as Pf Vf raised to gamma, then these two Vf will get added up. Powers get added up. Gamma plus 1 minus gamma is how much? 1. So it is nothing but this whole thing is just PFVF. Understood? This whole thing is just PFVF minus क्या PIVI. Yes or no? Divide by 1 minus gamma. Understood? This can also be written as very simply delta PV by 1 minus gamma. Okay, delta P by 1 minus gamma. Okay. And this P, because of ideal gas, because this is very important, because this is ideal gas, this PFVF can be written as it is NRTF, and this can be written as NRTI. Therefore, this is also NR delta T by 1 minus gamma. Okay, wait. So this is the derivation of adiabatic. ठीक है, वर्क डन कितना होता है NR delta T by 1 minus gamma. You can remember both these formulas. You can, मतलब ये दोनों formula you should remember. Okay, sometimes they will give you delta T के terms में, sometimes they will give you in terms of delta PV. Please remember, it is not P delta V, it is delta PV. Okay, it is not P delta V. Pressure is not same, so it's not P delta V, it is delta of PV. ठीक है? Sorry, can you please be louder or closer to the mic? Will they ask us derivation for exam? I don't. I mean, you should know this anyway. Okay. तुमको इसमें derivation में मैं एक बार फिर से I will go through it. Because the PV raised to gamma is constant, I am writing the pressure as K by V raised to gamma. Okay. K को outside लेके I am integrating 1 by V raised to gamma dV. It is simply 1 by x raised to n का integration is x raised to minus n plus 1 by 1 by minus n plus 1, which is I am writing x raised to 1 minus n by 1 minus n. Okay. So V raised to 1 minus gamma by 1 minus gamma. Okay. Now I'll put limits, initial and final. So after putting limits, you will get this. Okay. Then I will let the K enter here, this K, and there is K here. 1 minus ये वाला outside है. What is PV raised to gamma equal to K? You can expand it like this, that PI initial pressure volume raised to gamma is K is equal to PF VF raised to gamma. This K I am putting with the fine PF VF raised to gamma. This K I am putting PI VA raised to gamma. डाल दो, ये जो बचेगा खाली बचेगा PF VF raised to PF VF, just PF VF. It will just be PF VF, and this will be PI VI. Okay, so this is nothing but delta of PV. Now this PFVF from ideal gas can also be written as NRTF, ideal gas. Okay, so PIVA is NRTI. So this is NR TF minus TI. So it is also NR delta T. Understood? Okay. Now, it is sometimes confusing to from this equation with what is the sign of work is. Okay, because gamma, as you can see, gamma is always more than 1. Right? So therefore 1 minus gamma is a negative quantity. 1 minus gamma is a negative quantity, and delta T will positive or negative depend on the fact that initial pressure is more or final pressure is more. Okay. Sorry, initial temperature is more or final temperature is more. Okay. So you have to use your common sense in adiabatic process, and common sense says that, so forget this, whatever you find this, ठीक है, उसको तुम यू कैन रिमेंबर इट इज एनआर डेल्टा टी और बाय गामा माइनस 1 और एनआर डेल्टा टी बाय 1 जैसे तुमको याद रखना कर लो. ओके, नीचे वाला 1 माइनस गामा है, गामा माइनस 1, इट्स योर चॉइस, तुमको जो करना करो. ठीक, जस्ट गेट द आंसर एज पॉजिटिव. जो भी आंसर आएगा उसका पॉजिटिव लो पहले. ठीक है, नाउ यूज योर कॉमन सेंस इन द एडियाबेटिक प्रोसेस. वेरी सिंपल है. देख, Q इज इक्वल टू यू प्लस डब्ल्यू है. Q तो जीरो है. Q जीरो है, यस और नो? तो अगर वर्क हुआ, मतलब एक्सपेंशन हुआ, वर्क पॉजिटिव है, तो डेल्टा यू पक्का नेगेटिव है. Yes, if W is positive, delta U is negative. Yes, समझ में आता है ये? वर्क पॉजिटिव तुमको याद है ना कब होता है? वर्क पॉजिटिव कब होता है? जब एक्सपेंशन होता है। यस, है ना? और वर्क नेगेटिव कब होता है? जब कंट्रैक्शन होता है। और यू पॉजिटिव कब होता है? जब टेम्परेचर बढ़ता है। यस, और यू नेगेटिव कब होता है? जब टेम्परेचर कम होता है। ठीक, तो ये किसका, ये क्या एक्सप्रेशन है? वर्क एक्सप्रेशन है ना? ये सुनो, तुम्हें ये ढूंढना है कि एक्सपेंशन हुआ, कंट्रैक्शन हुआ, टेम्परेचर बढ़ा कि टेम्परेचर कम हुआ। अगर एक्सपेंशन हुआ है तो दिस क्वांटिटी शुड बी व्हाट? दिस शुड बी, this quantity which I've highlighted should be what? Positive. Yes. So तुम्हारे जो भी आंसर है तुम्हें पॉजिटिव लेना है, ठीक है? यू एडजस्ट योर डेल्टा टी इन गामा माइनस वन, वॉट एवर यू वांट टू राइट। ओके, ठीक। अगर टेम्परेचर बढ़ा, अगर टेम्परेचर बढ़ा, अब बताओ तब क्या होगा? डेल्टा, अगर टेम्परेचर बढ़ा तो डेल्टा यू क्या होगा?
Sir, delta U will increase, so W should increase. So W should be negative.
बोल डब्ल्यू शुड, ये मत बोल डेल्टा यू शुड, बोल डेल्टा यू विल बी पॉजिटिव। डेल्टा चेंज इज पॉजिटिव। ओके, इफ यू इंक्रीज, बोलो यू इंक्रीजेस, देयरफॉर डेल्टा यू इज पॉजिटिव।
Okay,
Delta U is positive, then work is
negative.
correct. Understood? ठीक. Now let us come to the graphs of PV pressure and volume. I'll just quickly go through once. Adiabatic, sorry, isobaric graphs ऐसे थे, straight line, horizontal. Yes. Isochoric ऐसे हैं, कोई डाउट है इसमें? नहीं. आइसोथर्मल जो थे वो ऐसे थे, यस, लाइक दिस, ये याद है ना? ओके, तो आइसोथर्मल अडियाबेटिक कैसा दिखता है देखो। इफ आई आस्क यू टू प्लॉट, अब थोड़ा सा मैथ से समझना, ठीक है? आइसोथर्मल था वाई एक्स इज इक्वल टू कांस्टेंट, यस और नो? द वाई एक्सिस इनटू एक्स एक्सिस, पीवी इज इक्वल टू कांस्टेंट, राइट?
Yes, sir.
ठीक है, सो लेट अस ट्राई टू प्लॉट दिस। इफ योर प्रेशर सच से 1 2 3 4 5 6, 1 2 3 4 5 6, देखो, लेट्स से the constant value is 16, ठीक है? We'll plot, try to plot yx equal to 16. So at, so we need more values, 1 2 3 4 5 6 8 7 8. Okay, do you understand that if y is equal to 8, x is equal to 2? समझ में आना? तो if I try to make xy plots of this, I will get 2 comma 8, 4 comma 4, 8 comma 2. समझ में आ रहा है ये? मैं प्लॉट कर देता हूँ ये पॉइंट्स, ठीक है? एक्सिस टू, I can take any one x, any one y, but nahi. Pressure, no, no, I can't take any one y. We should take the pressure as y, right? Because pressure is on the y-axis and volume as x. So x to 8, 2 comma 8 is this point, baby. 4 comma 4 is this point, and 8 comma 2 is this point, correct? And as you can see, if I join them, like you can make other points also, but I'm telling you that it will be like this, okay? Fine. Yeah, isothermal hai. I have explained you why. You can plot this, or you can just read your conic sections hyperbola, rectangular hyperbola. Xy is equal to c square, if you remember. Fine. The look say don't remember. कोई बात नहीं. देखो, adiabatic process, how is it different? This is iso, right? Because PV is constant. Adiabatic process मतलब y, प्रेशर तो प्रेशर ही है, लेकिन वॉल्यूम पे एक पावर है. जो पावर कितनी है न्यूमेरिकली, कितनी है वो? गामा का वैल्यू कितना है फ्रैक्शन में? ये कितना है? हाँ, फ्रैक्शन में कितना है ये? ऐसी अप्रोक्सीमेटली चाहिए मुझे, एग्जैक्ट नहीं चाहिए.
1.66.
1.66 ये वाला, 1.2 सम,
1.4.
1.4. ओके, सो दिस एक तो पावर है, The important thing here is the power जो है वो more than one है. It is more than one, not less than one. It is more than one, right? अगर ये more than one है, ठीक है, and that is a constant, ठीक है, तो यहाँ ध्यान से देखना. You have to tell कि you have to tell, देखो पहले x को वैल्यू मान लो 4 है, मान लो x की वैल्यू 8 है, ठीक है. So initially x equal to y is equal to 2 and x equal to 8 was satisfying this, right? But now 8 at x equal to, sorry, y is equal to 2, वो पॉइंट कौन सा था जिसमें y 2 है और x 8 है? नहीं, I will plot this point. X is equal to 8, so this is x is equal to 8, and so this is the point, right? Y is 2 and x is 8 was satisfying initially, right? But if there is a power on P, will 8 satisfy now here or not? What is it, number more than 8 or less than 8?
Less than.
Yes, it is less than 8. So let's say 7 is satisfied. Yes or no? समझा ना? तो ये जो नंबर है x, ये 8 की जगह 7 इधर आ जाएगा ना? अंडरस्टूड? सो देयरफॉर इसका जो स्लोप होता है एडियाबैटिक का, तो इसका ये कॉन्सेप्ट है कि स्लोप ऑफ एडियाबैटिक विल बी ऑलवेज ग्रेटर देन द स्लोप ऑफ आइसोथर्मल. द स्लोप ऑफ adiabatic will fall faster. Okay?
How can you repeat? I don't understand.
देख पहले ना x इक्वल टू 8, x पे 8 डालो और y को 2 डालो तो सेटिस्फाई हो रहा था क्योंकि 2 into 8 is 16. पर अगर x की पावर लग गई p, सम नंबर विच इज मोर देन 1, तो फिर 8 डालने पे तो 16 नहीं ज्यादा आएगा ना फिर. तो 8 की जगह क्या डालूं, यहाँ पे 2 रखूं और यहाँ पे व्हाट शुड आई पुट कि अभी भी 16 आए, क्या रखूं? 8 से कम रखना पड़ेगा ना. हाँ, तो मान लो 7 पे आ रही है, मान लो, तो दिस पॉइंट विल नॉट बी हियर, एडियाबेटिकली यहां हो जाएगा. सो एडियाबेटिक का क्या होता है? इट इज स्लोप इज हायर, स्लोप इज हायर, इट फॉल्स फास्टर. ओके, सो एडियाबेटिक falls faster than iso. Okay, adiabatic falls faster than iso. Done. Okay, so right, that there is something called a Carnot engine. Acha, before we do to Carnot engine, just write one thing, that if there is a process, going from 1 to 2, okay, the work done in 1 to 2 process is just the area under the curve. Work is area under the curve. So you find the area under the curve, and in this case the area will be this much area. It's always area of the PV curve, not any curve. And you can it is integral PdV, so you can get the reason why, right? That it is integral PdV. So integral PdV means area under the curve. Okay, so this area is the work done in the process 1 to 2. Okay, standard thing. Okay, so if you have a cyclic process, so yeah, have you understood that if work 1 to 2, yeah, it is area under the curve. Okay, so now if you have a cyclic process, let's say if you have a process in which you go from 1 to 2 and return from 3 to 4. Okay, so 2 to 1, so you go 1 to, so this process is 1 to 2 and then 2 to 1, cyclic process. Okay, so when you're going 1 to 2, work is positive or negative? So this is pressure, this is volume. If you do go 1 to 2, work is positive or negative?
Positive.
Yes, 1 to 2 work is positive, right? And 2 to 1 work is
Negative.
negative. So if I shade the 1 to 2, 1 to 2 work, it is the whole pink area, yes or no? Hmm? And if I shade the uh, 2 to 1 work, it is this much. Yes. So, and what is the network? It is the network done is work done 1 to 2 plus 2 to 1, right? So, but the 2 to 1 work is negative, right? So if you add this much positive area, see this much positive area, right? Total pink area positive, and you add to that green negative, what will you get? You will get only this much. Yes or no?
Hmm.
Yes. Yes. So this is that, therefore work done in a cyclic process is just area under the area between the matlab area enclosed by that cycle. Okay. So work done by a cycle is just the area not under but enclosed. Area enclosed. Understood? Okay. Now write one question, which one thinking question, that work done by a cyclic process is positive and work done by a work done by a clockwise cycle is positive. Work done by clockwise cycle is positive, whereas the work done by anti-clockwise cycle is negative. Why? So tell me why, Jivitesh.
So you told that in the cyclic process, work done is positive, and in the anti-clockwise or anti-cyclic, it is negative. So one possible reason can be when it is cyclic, the volume is also increasing.
The volume is
Increasing.
uh, you are there, but cyclic में क्या होता है वापस अपनी जगह पे आता है.
Sir, in anti-cyclic, it goes back. So yeah, so the volume is decreasing.
एक
Therefore,
एक clockwise है दूसरा anti clockwise है.
yeah, so in the clockwise, it increases, and like in the clockwise, it is the volume is increasing.
ठीक है, ये सोचना. ठीक है, ये गलत आंसर है भी, पर ये सोचना घर पे. एक क्लॉकवाइज साइकिल बनाना, ये जो मैंने बनाई है ना, ये क्लॉकवाइज साइकिल है. ठीक है, ये मैंने एंटी क्लॉकवाइज नहीं बनाई. ओके, इसको थिंक अबाउट इट, फिर मैं बताऊंगा. ठीक है, कार्नोट इंजन लिखते हैं. ठीक, कार्नोट इंजन लिखो. कार्नोट इंजन क्या होता है? This is a PV curve, and Carnot engine is an engine in which there are 4 cycles. Okay, so any engine if you want to run, it should be first, it should be a cyclic process. Okay, because you need to repeat that cycle. So the system must come to its original PVT, right? And there can be many cyclic processes like this. Okay, if you see this is a 2 isobaric and 2 isoporic process, right? Yes or no? This is one cyclic process. You can have this kind of cyclic process, simple cyclic process, right? So, right, understood? Any polygon you make, anything, any enclosed space you make, and then go say I want to go like this, it is a cyclic process. Okay, technically you can make an engine out of this. Okay, but out of all these, which is the most efficient? That is called the Carnot engine. In a Carnot engine, there are 2 processes. So there are, one is an isothermal expansion. So you're going from one place to 2 place, or let me call it ABCD. Remember, adiabatic was more slopey, right, than isothermal. So next is the adiabatic expansion. To see, okay, adiabatic expansion. The next is isothermal contraction. Isothermal contraction to D point, and the next is adiabatic contraction again to A. Okay, so the two reds are isothermal and two blacks are the adiabatic. Okay, समझ में आ गया ये? ठीक। अब देखिए, इस प्रोसेस में जो नेटवर्क होता है, नेटवर्क, वो तो आपको पता है साइक्लिक प्रोसेस है, ये साइकिल काउंट, ये क्लॉकवाइज है, तो इसका वर्क है ये इतना, ये सुनो, ये ग्रीन है ना? ठीक है, ओके। अब थोड़ा सा वन ए टू बी देखते हैं। तो ए टू बी कैसा है? एक आइसोथर्मल प्रोसेस है, ये सुनो। ठीक। अच्छा, आइसोथर्मल प्रोसेस में क्या जीरो होता है बताओ?
Sir, in isothermal temperature is constant, so delta T is 0.
And therefore out of Q, U and W,
Therefore, PV will be constant.
क्या क्या कांस्टेंट?
PV,
Out of Q, U and W, what is zero?
U will be 0.
yeah.
U will be zero. Therefore Q is equal to W is equal to, वर्क का फॉर्मूला था NRT QAB is equal to WAB is equal to NRT ln VB by VA। ये तो याद है, ये समझ में आया? क्योंकि आइसोथर्मल पे टेम्परेचर सेम है जी, आई डोंट नीड टू राइट TA एंड TB। ओके, by the way, this temperature I am going to call T1, and this temperature isothermal I am going to call T2, okay, and this is my temperature T1, okay। T1, T1 हायर है, T2 हायर है, बताइए, याद है ना? isotherms, higher isotherms lies where, which is higher, T1 or T2?
Thirty.
T1.
Yes, T1 is higher, very good, T1 is higher, okay। Let us talk about the adiabatic process, which is from B to C। In B to C adiabatic process है, तो what is zero? Sorry,
Q.
very good, Q is zero, therefore
U would be 0.
U is equals to minus W or negative work.
UBC or delta UBC is minus WBC, and delta U is always what? It is NR delta T, so it is T2 minus T1. Do you understand? The temperature at this point is T2 and at this point is T1, so it is, sorry, NR नहीं, NCV है ना? Delta U is NCV delta T, right? सही है ये? सही, correct है? Delta U is always NCV delta T, so I am just writing delta U is NCV T2 minus T1, ठीक है? And the work done is also negative of that because delta U is minus delta W, okay? Fine, okay. Next process, which is the isothermal from C to D. Iso from C to D. It's an isothermal compression, okay? So again, QCD is equal to WCD is equal to nRT2 ln of VD by VC, है ना? समझ में आई है? ठीक है, अब इसमें एक चीज देखना, देख, अच्छा ये बताना, VB बड़ा है कि VA बड़ा है? यहाँ पे VB बड़ा है, VA बड़ा है?
Sir, VB.
VB बड़ा है, अगर VB बड़ा है तो VB by BA, VA मोर देन वन है, लेस देन वन है?
More than
मोर देन वन है। और जब भी तुम लॉग मोर देन वन का तो पॉजिटिव आता है, ठीक है? लॉग मोर देन वन क्या आता है? पॉजिटिव। और लॉग अगर नंबर है तो वो नेगेटिव आता है। ओके, गिवतेश म्यूट। ओके, तो ये जो नंबर है यहाँ पे देखना ध्यान से, थोड़ा मैं जूम कर रहा हूँ यहाँ पे। वर्क क्या था इसमें? nr t1 log vb by va। ये लॉग पॉजिटिव है कि नेगेटिव?
सर पॉजिटिव।
देयरफॉर ये पूरा वर्क पॉजिटिव है, जो दिख भी रहा है, होना भी चाहिए। ये एक्सपेंशन है तो वर्क पॉजिटिव है ना? यस। और यहाँ वाला वर्क देखोगे तो vd बड़ा है, vc बड़ा है? बोलो भाई जल्दी।
सर वी सी।
vc बड़ा है, देयरफॉर vd by vc is less than 1।
हाँ
Therefore, this number is negative. Okay, guys, have you understood this? Okay, so this is for the work done in sorry, isothermal, and the last is again adiabatic compression from D to A, and in D to A, the Q is zero again. Q is zero, so the delta U dA is equal to minus W dA is equal to NCV T1 minus T2। सही बात है? NCV delta T, no? Final temperature is T1, initial is T2, so it is delta T is NCV T1 minus T2। अच्छा, ये पता है ना, वो CV एक ही चीज है, मतलब C और V अलग मल्टीप्लाइड नहीं है, इट इज C सबस्क्रिप्ट V। एक गलती मत करना, ठीक है गाइज? अंडरस्टूड? नाउ सी। Okay, listen, what is an engine? Engine is a device which you give heat, it does work। Okay, so let's say diesel engine, which is in a car, or a petrol engine. Okay, engine, what does it do? It takes up what?
इट टेक्स अ फ्यूल,
Fuel। फ्यूल बर्न होता है, बर्न होके क्या देता है उसे?
हीट
Heat।
एंड वर्क।
तो इन वर्क नहीं, इनपुट क्या है इंजन का? किसी भी इंजन का इनपुट इज क्यू। ओके, and why are you using this? Any engine you are using to convert it to energy, to convert your heat to energy. I'm using a car engine because I want to drive the car. I want to uh, basically I want to give kinetic energy to the wheels. So I want to convert heat to energy. Okay. If you give 100 joules heat to an engine and it converts 100 joule of that heat to work, then it is a hypothetical engine। मतलब it's a best engine, efficiency is 100%, but it is not possible। Understood? All Any engine in the world will never convert 100% of the given heat to work। Okay,
सर व्हाई इज दैट?
so that is because second law second law of
और थर्मोडायनेमिक।
prevents it। Okay,
ओके अंडरस्टूड।
details will go in the next class। Okay, I will take an extra class on second law, but details not here। So any engine, if you give 100 joule to it, let's say if it does 80 joule of work, 20 joule will be waste heat। It will reflect, like it will it rejects 20 joule of heat। Okay, that 20 joule goes to waste, and 80 joule, let's say if it is useful, then efficiency we say is 80%। Understood? Point 8। समझ में आया ये कॉन्सेप्ट? फिर से सुन लो कॉन्सेप्ट। If you give Q to a engine, out of that Q, it will, Achha, delta U of engine is always zero because you are anyway, it's a cyclic process। So if it is a cyclic process, you are going to the same point। If you're coming to the same point, your temperature is same, right? So delta U will of a cycle is always zero, so don't worry about delta U। All the Q which you are putting, if you give Q input, the engine Q in में से W क्या करता है कि W का वर्क करता है और सम Q आउटपुट वेस्ट कर देता है। ओके, तो Q in इज इक्वल टू W प्लस Q आउट होता है इंजन में, ठीक है? समझ में आया ये यहाँ तक? हेलो गाइस।
Yes, sir.
अब कितना परसेंट डब्ल्यू में जा रहा है, कितना परसेंट क्यूआउट में जा रहा है, वही डिसाइड करता है इंजन की एफिशिएंसी। मान लो 100 है और 90 वर्क कर दिया और 10 फेंका, तो इट्स अ वेरी गुड इंजन। इसका एफिशिएंसी कितना है?
So 90%?
100 में से 70 यूज किया, 30 फेंका, तो एफिशिएंसी 70%।
Yeah.
नॉर्मली जो कार्नोट इंजन भी है, जो बेस्ट इंजन है, इसका भी जो एफिशिएंसी है वो है लगभग लगभग 30 से 40% एफिशिएंट है ये। मतलब 30 से 40% यूज करता है डब्ल्यू, और बाकी 70 क्या करता है ये? खराब कर, वेस्ट। ओके, सो द बेस्ट इंजन्स, इट इज, ये तो उसका थियोरेटिकल लिमिट है, इट्स नॉट इवन अ प्रैक्टिकल लिमिट, इट इज अ थियोरेटिकल लिमिट। whatever ये जो second law prevents you from efficiency getting 100%, it's not a practical limit, it's a theoretical limit. You should understand the difference. What is the difference between a practical limit and a theoretical limit? You might have read Huygens uncertainty principle, which, what can you describe, like what you are studying in that?
Sir, like as long as I remember, it is like you cannot determine the exact position and velocity of the electron.
Correct. And why is that? Why is that? Why do you think is that true? That is true.
Because when we find its velocity, by that time its position would have changed. And if we are checking its position, by then its velocity may be different.
Yes. And why do you think we are unable to find position and velocity at the same time very precisely? I mean, like I can perfectly, if I throw a ball, I can perfectly, using a still motion camera, at some point of time, I can click the photograph and tell you, oh, ball is that point, and it's the velocity it is at going at that speed, right? So is it like we don't have good enough cameras or what?
An electron,
Good, good. Please continue.
uh, an electron is microscopic, so it acts as both a wave and a particle.
Yes. So it is not as if we don't have good enough cameras. Even do we, if we have the best cameras ever possible, you cannot determine the position and velocity simultaneously. It has something to do with the very intricate nature of electron. It's a theoretical limitation. It is not a practical limitation. Understood? Same way, the efficiency not being 100% is not a practical limitation. It's not because of friction. It is not of heat. There are other जो practical limit होता है ना, why engine will, so suppose theoretically you will say the efficiency of this engine is 50%. Okay, let's say some engine is 50%. When you actually run that engine, it will give you only 20%. That is a practical engineering. Say you are, some heat is lost as friction, some gases escape, there is friction, or there is some other kind of drag, there is viscous forces, so that is different thing. Fifth, ये जो limit है, this is theoretical. Okay, so I hope you have understood the theoretical limit and the practical. Okay, so now,
Sir,
yes,
so then what is the efficiency of the engines that we use in the car nowadays?
yes, I am not sure, but is that a Carnot engine? If I don't think that's a Carnot engine either. Carnot engine was the first engine which was made and commercially used. Trains used it. I don't think that. I don't know. You, I have to check, but these days car don't have Carnot. They have internal combustion engine with something else. I'm not very sure. Okay,
Okay,
I'll check and let you know.
okay.
But Carnot was the first and the most widely used heavy engine.
So
Okay,
now it is not used.
I'm not sure.
Okay.
Sure. Okay. So yeah. So इन दिस, ये वाला जो साइकिल आइसो अडिया और फिर आइसो अडिया, इसमें जो इनपुट हीट है ना, इनपुट हीट वो इस प्रोसेस में होती है, ए टू बी। ओके, इनपुट हीट इस प्रोसेस में होती है, इसमें तो एनीवे इनपुट तभी होता है जब एक्सपेंशन तुम डाल रहे हो, ठीक है। इन दो प्रोसेस में इनपुट होता है, लेकिन ये तो एडियाबेटिक प्रोसेस है, तो इसका तो क्यू एनीवे जीरो है। ओके, तो नेट देयरफॉर क्यू सिर्फ किस में होता है, इसमें होता है क्यू। अंडरस्टूड? क्यू इनपुट किस में होता है, सिर्फ और सिर्फ इसमें, ठीक है। इसमें क्यों नहीं होता, लॉजिकली होना चाहिए, बट ये तो एडियाबेटिक प्रोसेस है। किसी भी एक्सपेंशन में क्यू होना चाहिए, क्यू इनपुट, बट एडियाबेटिक है तो एनीवे नहीं, आइसो में है, ठीक है। तो व्हाट इज क्यू इनपुट? तो यहाँ पे इंपॉर्टेंट है एफिशिएंसी, देयरफॉर क्या हुई, ये डब्ल्यू बाई क्यू इनपुट हुई, समझ में आया ये? एफिशिएंसी, दिस इज द सिंबल फॉर एफिशिएंसी, ईटा। एफिशिएंसी इज डब्ल्यू बाई क्यू इनपुट, यस और नो गाइस? गॉट इट? तो W तो पता है ना, ब्लू शेडेड रीजन है, यस। और W आई कैन फाइंड आउट बाय डूइंग W1 प्लस W2 प्लस W3 प्लस W4, यस और नो? दीज आर फोर वर्क्स। कौन कौन से फोर वर्क्स हैं? एक है वर्क ये वाला, एक है वर्क ये वाला, एक वर्क ये वाला, और एक वर्क ये वाला। अंडरस्टूड? हाँ, ठीक। और नीचे क्या है, क्यू इनपुट। क्यू इनपुट होना चाहिए किसमें, Q1 प्लस Q2, बट Q2 इज एनीवे जीरो। ओके, सो इट इज जस्ट Q1। इफ यू पुट वैल्यूज, W1 का वैल्यू है, ये ध्यान से देखना, ठीक है। W1 का वैल्यू है NR-T1 ln VB बाई VA, ये सर नो, ठीक। WBC का है माइनस ऑफ दिस थिंग, बिकॉज इट इज, यहां देख लो, WBC इज नेगेटिव ऑफ दिस, ये सर नो, ठीक। WCD इज straight away this, and WDA is negative of this, ठीक। अगर तुम ध्यान से देखो, इफ यू ऐड दीज टू, डू दे कैंसिल ईच अदर, यस और नो? तो इनके नेगेटिव भी कैंसिल होंगे। if these two, if you add them directly, do they cancel each other? Yes, therefore the negatives will also cancel, yes। अगर ये +5 और ये -5 ऐड होके जीरो हो रहा है, तो इनको नेगेटिव करके भी तो ये जीरो होंगे ना?
Yes.
यस, ओके। तो इनको इनको मैं इग्नोर मार देता हूँ, ये W2 और W4 ऐड करके जीरो आ रहा है ना?
Yes.
W1 क्या है, W1 है NR-T1 ln VB बाई VA, NR-T1 ln VB बाई VA, प्लस W3 जो है वो है NR-T2 ln ऑफ VB बाई VC, VB बाई VC, ठीक है। डिवाइडेड बाई Q1, Q1 इज हाउ मच, Q1 इज NR-T1 ln VB बाई VA, N
So for W3, isn't it supposed to be NR T2 ln VD by VC?
सॉरी सॉरी, ये यहाँ पे गलत कर दिया मैंने, ब्रैकेट में वॉल्यूम ना,
Hmm.
ब्रैकेट में वॉल्यूम जो है वो है VD बाई VC।
Yeah.
समझ आ गया यहाँ तक? अब देखो, ये टर्म दोनों सेम है, एकदम सेम है, तो मैं इसको लिख देता हूँ 1 प्लस, है कि नहीं, है ना? और इसको जब अलग अलग करोगे तो NR NR जाएगा, आएगा T2/T1 ln VD/VC बाई ln VB/VA, ये आएगा, हाँ, ठीक है। अब तुम्हें क्या लिखना है, आ, ये जो चीज है ना, ये पूरी, ये ln VD/VC डिवाइड बाई ln VB/VA, ये होती है -1। ये होती है कितनी, -1। मैं तुम्हें बताऊंगा क्यों होती है, अभी नहीं बता रहा, पर ये होती है -1, ठीक है। मैं बता दूंगा, इसको स्टार मार्क कर लो, बाद में बता देता हूँ, ठीक है। मैं एक फोटो भेजूंगा, उसमें तुम्हें समझ में आ जाएगा, ठीक। ये -1 होती है, देयरफॉर इट इज 1 माइनस T2/T1, ठीक है। T2/T1 बोलना थोड़ा अजीब है, तो मैं बोलता हूँ T लोअर बाई T हायर, सो दिस विल कीप यू रिमेंबर, इट इज 1 माइनस T लोअर बाई T हायर, ठीक है। तो एफिशिएंसी ऑफ कार्नोट इंजन इज has a theoretical limit and its value is 1 minus T lower by T higher, ठीक है बच्चों? ये फॉर्मूला है, ये आता है, ठीक है, कि कैसे डिराइव करते हैं।
Sir,
हम्म,
my exam is tomorrow, so can I take a leave, preparatory leave?
when
Uh, in couple